Welcome to aminacademy.com. In physics, formulae and their explanation, we will discuss about physical quantities, symbols, and units and dimension of a most important physical quantities. This type of table is more useful to understand the physics basics. First, the fundamental physical unit quantities. We know that mass, length, time. These are fundamental quantities: electric current, amount of substance, luminous intensity, and temperatures. These dimensions, look at this: mass is m, length is L, and time is t. This is a basic MLT system. And current is IRA, we have to use it. Amount of substance N, luminous intensity J, and temperature K or theta. This units also given. Mass is in kg, length is meter, time is seconds, electric current ampere, amount of substance mole, luminous intensity candela, and temperature Kelvin. From those units, we can derive some other physical quantities. Now first, look at here, this is called derived physical quantities. First one is area. Area, we know that L into B, length into breadth. L is the this unit of physical quantity is meter square. The dimension is m0. The dimension is m0 L cube. For area is m. There is no mass. M L square T0. Then volume. Volume is L into B into H. That is meter cube. That is m0 L cube T0. That is L cube only available and other m and T are zeros. Density, mass per volume. Mass per volume, here mass is m, L is in denominator, L is, that is volume is L cube minus 3 and there is no time, T0. Then specific gravity. Specific gravity is density of substance by density of water. Here all are zeros because this is a specific gravity. There is no unit since it have the ratio of the same things. Next, frequency. Frequency is number of vibration per time. Number of vibrations is no unit for mass, no unit for L. Time is per second, that is t power minus 1. This unit is hertz. Angle. Angle is arc by radius. Arc by radius, there is no, here m0, L0, is no unit in MLT system. Then velocity. Velocity is displacement by time. Here displacement means L, and first m, start with m, there is no m, that is m0, m0, L is what? L is 1, time is minus 1. That is a displacement by time. By time is t power minus 1. So m0, L1, t power minus 1 meter per second. Speed, distance by time. Distance is, that is m is 0 because there is no mass. L1, t power minus 1. This is easy. Meter per second. Here, next, speed. Speed also velocity without direction. So this distance by time, say m0, L1, t power minus 1 meter per second unit. Aerial velocity. Area by time. Area is L square, that is t power minus 1. Whichever not there, you have to use it zeros. M0 L square t power minus 1, that is meter square per second. This is for aerial velocity. The next one is acceleration. Acceleration is change in velocity by time. Change in velocity is, already velocity is m0 L1 t power minus 1. Another time is denominator, so t power minus 2. The next is linear momentum, m into v. Here m into v is mass is 1, L is 1 by time, because L power 1 t power minus 1 is the velocity. So mass into velocity is linear momentum. That is a kg meter per second. Next is a force. Force is mass into acceleration. So which is m1 L1 t power minus 2. Acceleration is L1 t power minus 2. That is m1 here. So kg meter per second or Newton. This Newton is, we can say, unit of force is Newton. So this is there for force. Weight is also a force. Weight is a gravitational force. Mass into gravity, same unit of m1 L1 t power minus 2 kg meter per second or Newton. Next is moment of force, torque or couple, all are same, which is equal to force into arm. Force is already kg meter per second, another arm is length. So totally m1 L2 t power minus 2. Impulse, force into time. Force is already m1 L1 t power minus 2 and into t, that is t power minus 1. That is, we can say it is a force into time is kg meter per second or Newton second. This is the unit. Pressure. Pressure is force into area. The unit is m1 L minus 1 t power minus 2, which is the unit is Newton per meter square or Pascal. Work. Work is like energy, force into distance, which is derived by m1 L power minus 2 t power minus 2. This unit is Newton meter or joule. Next is kinetic energy. Kinetic energy is half mv square. Half no unit. M mass is m1. V square is L square into t power minus 2 joule. Kinetic energy is also joule. Potential energy mgh. This is also joule. m1 L power 2 t power minus 1. Next is gravitational constant. Gravitational constant, look at here, force into L square by mass square. For example, we'll derive this one here. Force, mass into acceleration, L, m is mass, acceleration is L by t power minus 2 into length is L square over mass is m square. So finally cut these things. So we have L power L cube t power minus 2, that is L cube t power minus 2, mass is m minus 1. So we have m minus 1 L cube t power minus 2. We derived this one. Like we can derive your that MLT system of this constants. Next one, gravitational field strength. Gravitational field strength is force by mass. So m0 L power 1 t power minus 2 Newton per kg. Gravitational strength. Gravitational potential, work per mass. Gravitational potential is work per mass. Work is already joule per kg. This dimension is m0 L square t power minus 2. Force constant K, force F by L, force divided by length. So Newton per meter. So m0 m1 m power 1 L0 t power minus 2. Power is work by time. Work by time, that is m1 L square t power minus 3. That is joules per second here. Work. Next one, moment of inertia. Moment of inertia is mass into distance square. M L square t power 0 kg meter square. Stress is force by area, that is m1 L power minus 1 t power minus 2 Newton per meter square or Pascal. So stress. Next is strain. Strain is change in length by original length. So there is no unit because the ratio of same units. So M0, L0, T0, here no units. Modulus of elasticity, that is stress by strain, M1, L power minus 1, T power minus 2. That modulus of elasticity is Newton per meter square or Pascal. Poisson ratio. Poisson ratio is sigma is Y over 2n minus 1. There is here Poisson ratio, no unit. So M0, L0, T0. And velocity gradient. Change in velocity by distance. Change in velocity per distance. M0, L0, T power minus 1. That is a velocity gradient. Velocity gradient is only second per second. Coefficient of dynamic viscosity, that is tangential stress by velocity gradient. So this is M1, L power minus 1, T power minus 2. This unit is kg per meter per second. It's called a Poisson also. Then surface tension, force per length. Force per length is surface tension. M0, M power 1, L0, T power minus 2. That is kg second square. Other unit is Newton per meter. Force by length. Angular displacement theta or by radius. Here M0, L0, T0. No unit is MLT. Here no unit for angular displacement. Next one, angular velocity. Angular velocity is angular displacement by time. So M0, L0, T power minus 1. That is radian per second. Angular acceleration, changing velocity by time. M0, L0 by T power minus 2. Radian per second. Radian, no unit, T power minus 2. Because change in angular velocity is already per time, one more per time is there, so it is second power minus 2. Angular momentum, I omega, is m L square T power minus 1, that is kg meter square per second. Angular impulse, I omega, angular momentum and angular impulse is same unit, so m L square T power minus 1, that is kg meter square per second. Temperature is theta or K, Kelvin or degree Celsius or MLT system. Coefficient of linear expansion, that is coefficient of linear expansion is change in length by original length into temperature T2 minus 1. Here change in length by original length no unit, per temperature is here MLT is all are zeros, M0, L0, T0, but K power minus 1. K is a unit of Kelvin. Specific heat, energy per mass per time. Energy divided by mass into time. So M0, L2, T power minus 2, K power minus 1. Then latent heat. Latent heat is energy per mass. Latent heat is energy per mass, that is M0, L power minus 2, T power minus 2. Joule per second, joule per kg. Entropy is Q over theta. That is M1 L square T power minus 2 K power minus 1. That is joules per Kelvin. Thermal capacity is H over theta. That is heat. Thermal capacity is energy by theta. That is M1 L power 2 T power minus 2 K power minus 1. That is thermal capacity. That is joules per Kelvin. Next is gas constant. PV over T, that is MRT. This is the gas constant, or here M0 L square T power minus 2 K power minus 1 joules per Kelvin. Coefficient of thermal conductivity, that is thermal conductivity is QD over A area into theta minus theta 1 temperature change into time. So M0 M power 1 L power 1 T power minus 3 K power minus 1, that is watts per meter per Kelvin. Pole strength, that is ampere into meter. Pole strength M0 L1 T power 0 I, because meter is L power 1 here and I as it is, that is AM pole strength. Next is magnetic moment is M0 L2 T0 I power 1, that is ampere meter square. Magnetic flux M L square T power minus 1 I power minus 1, it's a Weber. Unit of magnetic flux is Weber, that is T meter square. Next one, magnetic field, magnetic flux density is M T power minus 2 I power minus 1, is a Tesla. Unit of Tesla is joules per ampere meter square. Permeability of free space, mu by mu r, that is here M L T power minus 1 I power minus 2. Magnetic susceptibility, also called volumetric or bulk susceptibility, xm equal mu r minus 1, that is m0 l0 t0, no units. That is electric charge. Electric charge is I into T, that is here m0 l0 t power 1 l power I power 1. Ampere second or coulomb. Then electric potential, work by charge. This unit is m1 L square T power minus 3 I power minus 1. This is volt. Electric potential is volt. EMF also volt, the same unit. EMF and electric potential is same. Electric capacity Q over V. M power minus 1 L power minus 2 T power 4 I square, farad. Electric capacity. Next one, electric resistance V by I. M0 M power 1 L square T power minus 3 I power minus 2 ohms or volt per ampere. Electric resistance. Resistivity RA by L, that is M0 M1 L cube T power minus 3 I power minus 1. Unit is resistivity is ohm meter. Conductivity sigma is 1 over rho is M power minus 1 L power minus 3 T cube into I. Conductivity, that's Siemens per meter. Permeability, that is epsilon equal to epsilon r into epsilon 0, which gives here M power minus 1 L power minus 3 T power 4 I square, farad per meter. Electric conductivity is 1 over R, the opposite of reciprocal of resistance is electric conductivity, that is M power minus 1 L power minus 2 T cube I square. Siemens or moles. Electric power V into I, M1 L2 T power minus 3 I power minus 1, it's a watt, unit is watt. Electric impedance V over I, that unit is M1 L square T power minus 3 I power minus 2 ohms or volt per ampere. Electrical impedance is that. Electrical admittance 1 by Z, reciprocal of electric impedance. This self-inductance V equal to L di by d theta, that unit is M L square T power minus 2 I power minus 2. Boltzmann constant, energy by temperature, these are the units. Stephen constant, coefficient of friction mu F by N, force by normal reaction. No units because coefficient of friction is unit fraction of two same units. Dielectric constant is also called relative permittivity, dimensions less, no unit. Planck's constant H P equal to HV. The Planck constant is M L square T power minus 2 joules second or electron volt into second. Refractive index mu, no units, M0 L0 T0. Focal length, distance between center of the lens or mirror to its focus L, that is here only, that is M0 L1 T0 meter. Power of lens, the reciprocal of the focal length of a lens in meter is called a power of lens, that is L power minus 1. We can say M0 L power minus 1 to 0. Wave number of waves per distance, that is per second. That is per meter. Per meters are not per second. Per meter, m is 0, L is minus 1, is 0. Wavelength, length of waves L. So meter unit is m0, L is 0. So far we discussed some important physical units and its dimensions. Physical, that is physical quantities, their formula and dimensions and units. We have done. Please subscribe our YouTube channel.